Hi. We're back. My name is Douglas Gomer. I'm president of the United States National Committee of the International Conference on Monuments and Sites. This is the second session for today. We're going to be talking about managing climate change at World Heritage Sites. The next presentation is on the Climate Variability Index, CVI, as well as Climate and Heritage Team on the issues of climate change at heritage sites. And in this case, the title of the presentation is Sea Level Rise, Restoration, and the Future of the Everglades. And this should be absolutely fascinating because it is an enormous challenge. So Dr. Evelyn Gaiser, who's a distinguished university professor of biological sciences and holds the Georgia Barley Jr. Eminent Scholars Chair at Florida International University. She's an aquatic ecologist. Sorry, I'm an archaeologist. She's an ecologist whose research is focused on international university, is focused on what algae can tell us about the consequences of climate and land use change to lakes and wetlands. She's published over 120 peer-reviewed publication and book chapters. For 15 years, she led the Florida Coastal and Everglades Long-Term Ecological Research Program, which is only one of 28 such programs founded by the National Science Foundation, which is incredibly prestigious. Also, she's a musician, which is really interesting. She has a PhD from the University of Georgia, and she has, as a trained musician, she's creative works to express science through music, and I'd love to hear that. So no further ado, I'd like to ask Dr. Gaiser to present on her topic, which is sea level rise, restoration, and the future of the Everglades. Thank you.
Well, thank you so much for that introduction, and just thrilled to be a part of today's symposium, and thank you so much for the invitation to talk about sea level rise and climate change and the future of our Florida Everglades. Many of you probably know that the Everglades is this big, expansive wetland. It's an unusual type of wetland in South Florida. It's one that Marjorie Stoneman Douglas wrote about in her book, River of Grass, published in 1947. And she said, there's no other Everglades in the world. They are and always have been one of the unique regions of the world, remote, never wholly known, and nothing anywhere else is like them. And for these reasons, parts of the Everglades were protected by Everglades National Park that was founded in 1934. A UNESCO World Heritage designation came in 1979. And then more recently, the World Heritage in Danger designation in 2010. I like to think about the Everglades as an iconic ecosystem. It has a lot of unusual plants and animals like those shown here, many of which are threatened or endangered. It's also iconic for its people that have occupied it for its entire history. It has a lot of unusual functions, and just as an example, there are these vast carpets of algae that form mats of cyanobacteria and other algae, and those float around on the surface of the Everglades, and they provide little homes for tiny aquatic animals, and they're really the base of the Everglades food web. So indeed, it's really a spectacular ecosystem with enormous diversity at all levels. But it's also an exceptionally vulnerable ecosystem, especially to the accelerated rates of sea level rise that we're experiencing today. And that vulnerability results from its very low topographic relief, which with most of the ecosystem being less than 5 and up to 10 meters above the elevation of the sea as it stands today. The Everglades is also underlain by a really porous limestone bedrock, and that allows for fresh water to percolate down into a very precious aquifer beneath the Everglades that supplies 9 million people with fresh water. And that aquifer is really being threatened because that same porosity allows salt water to intrude as the sea level comes up. Well, the Everglades is highly threatened, and that's what resulted in this designation of it as a World Heritage Site in danger. And those threats come from so many different angles, beginning with the 20th century dredging that was super extensive. And it resulted in the expansion of urban areas and agricultural areas throughout the state. And that agricultural development in particular polluted the interior of the Everglades that is very susceptible to pollution because it's naturally so pristine. Other threats include one that you've probably seen about on the news, lots of different species coming to the Everglades from all over the world and making a home there, like the Burmese python. So many non-native species now take up their homes there. And now, of course, we have the different climate pressures, particularly the increased frequency of really severe tropical storms that continue to increase in severity, and the relentless press of sea level rise. Well, these factors have been recognized as important threats to this ecosystem, and as a result, the Congress authorized in 2000 the Comprehensive Everglades Restoration Plan. We know that this ecosystem was once really fully connected to this upper watershed that allowed fresh water to come all the way through Lake Okeechobee and move as sheet water all the way down into the estuaries of the coast of Florida. And then thousands of miles of canals were dug to convert that land into agricultural and urban areas, and that reduced the extent of the Everglades and also compartmentalized it and caused that precious fresh water to be then dumped out to the sea, where it does all kinds of other damage. Now, the goal of the restoration plan is to rip out many of those barriers to flow and restore the connections into the Everglades itself, restoring and replenishing that aquifer and supporting all of those iconic ecosystem structures and functions. And that restoration is rapidly underway. And our big question is whether or not we can recover those unusual and distinctive features of the system, especially given these accelerating threats that climate change brings. This question of how climate change and freshwater restoration will interact with all of these iconic ecosystem structures and processes to determine the values of multiple ecosystem services to the growing populations of South Florida is really the focus of our National Science Foundation funded Florida Coastal Everglades Long-Term Ecological Research Program. And that's been in place since the restoration plan was authorized in 2000. And we've been collecting data and collaborating interdisciplinarily throughout this ecosystem along sites that are arrayed along transects that include freshwater ridges and sloughs, down through our tidal mangrove forests and out into the beautiful seagrass meadows of our coastal estuaries. And so we consider the fate of these ecosystems to very much be determined by this balance of freshwater delivery that's controlled so much by what we do through freshwater management and restoration, and marine water delivery that comes further and further every day into the system via our tides and more frequently than ever with large tropical storm surges and relentlessly with that rising of sea level. Well, one of the aspects we measure routinely at our LTER sites is the rate at which these ecosystems are trapping atmospheric carbon and then sequestering it and putting it down into soils and transporting it to adjacent ecosystems. And what our work has shown is that over the history of the ecosystem, the ability of the marsh to capture and store this carbon is greatest in the place where the fresh and marine water supplies meet in these mangrove forests. And so protecting such wetland sinks of carbon that are part of what we call blue carbon is really important, not only for the global carbon budget that global wetlands contribute to substantially, but also for the future of these wetlands that depend on these elevation gains that come from accruing carbon. Well, sea level rise is causing rapid intrusion into the Everglades, and this graph shows the seasonal bouncing around of sea level, but also a continuous rise over time that's moving saltwater overland and underground into the Everglades. And these contours are showing that movement inland of saltwater intrusion, threatening that aquifer that is so precious in our Biscayne aquifer that supplies so many people with fresh water. And now this interior movement of salt, that's been going on for millennia with the slow rate of sea level rise that actually allowed for the Everglades to form and take up its current configuration. And at that rate, sea level rise, of slow sea level rise, mangroves are able to invade and keep up with the rate of sea level rise by building soils as they grow and die and continue that soil building process at that historic rate of sea level rise. But with current rates of really rapid saltwater intrusion, amongst the highest rates of sea level rise that are recorded on the planet are happening here in South Florida, we're finding areas where the freshwater marsh is seeing saltwater for more days of the year than it ever has, and it's not used to that. And the plants that occupy these marshes are dying, and that's causing a really rapid degradation of these communities. And the collapse of those soils that represent thousands of years of accumulated carbon are liberating now to the atmosphere and causing these open water pools where mangroves just can't keep up with that pace of saltwater intrusion. We've been conducting lots of experiments to understand why this is happening, exposing freshwater plants to salt, and we find that that kills the plant roots, and it again mobilizes those soils to the atmosphere, even if we add nutrients that are limiting in the system. And so it reduces that blue carbon storage capacity. But really interestingly, we find that when tropical storms come through with storm surges, they dump a huge load of sediment, shown here, into the forest floor, and that sediment contains nutrients that allow for the forest to really rapidly recover. And that soil, the sediment that's dumped in there results in an elevation gain. And so these storms, when they have these surge dumps that they do, paradoxically increase the forest resilience to sea level rise. Well, we're also using acoustic tracking techniques and isotope studies to track energy and nutrient movement by a number of different consumers, including fish and dolphins and gators. And we track how they move these energy sources up and down the estuaries, and they're actually responding to and feeding back to the kinds of changes that we're seeing in the plant communities there and in the storage and accumulation of carbon. Well, it's been a long time coming that we've been waiting for Everglades restoration, and that's finally happening. We have new pump stations installed along canals, levees being ripped away that once blocked freshwater flows, new bridges to restore hydrologic connectivity to the system. And this is bringing more fresh water than ever, or than we've seen in many, many years into the system. And this graph is showing the relationship between cumulative rainfall and cumulative flow that's steepening over time with the successful implementation of each of these projects, delivering more and more fresh water into the system. We still have a very long way to go in the scope of Everglades restoration, but we are seeing some restorative effects. We're engaging in modeling efforts to determine how freshwater restoration influences ecosystem resilience to sea level rise. And we're finding that scenarios that include freshwater restoration at the same time that sea level is rising by time for soils to build and for the system to adapt to sea level rise as we move more freshwater restoration in compared to scenarios without restoration. However, we're currently losing soils in these ecotone regions shown in blue here, and we'll never get those soils back. So restoration takes on this added urgency in the light of climate change. President Obama recognized this. He visited us on Earth Day in 2015 and advanced some really important policies to get those bridges that I showed you built and authorized and built. And now we're working closely with stakeholders and the public to evaluate different restoration scenarios that result in not only an improvement and restoration of ecosystem structures and functions that are so iconic of the system, but also of the different ecosystem services like our freshwater supply, our fisheries, our carbon sequestration that are so important to Floridians and people all around the world. And so often when we talk about fixing the Everglades, we say if we can fix the Everglades, then maybe we have a chance to fix other wetlands all over the world that are threatened by similar ongoing pressures. So I want to thank my colleagues in the FCLTR program, our funding agencies, which are numerous. And if you want to learn more, you can read about more about the Everglades in our book, The Coastal Everglades, and visit our website that has much more information of the sort that I talked about today. So thank you so much, and I'll stop sharing screen.
That was terrific. A little bit complicated, just a trifle complicated, but it's a big challenge. I think I'd like to go through those slides one at a time and think carefully about each one of them. But thank you so much. Hopefully it's just a way to open up a conversation. I think these are huge issues in many places in the world. So I would thank you again, and I would like to introduce our next speaker, who is going to be talking about, well, this is the title of his presentation, The World Does Not Stand Still, Assessing the Effects of Climate Change. And here we go again, Papahanaumokuakea World Heritage Site. And I've practiced that 1,000 times, but I think the real answer is I just have to move there and spend about 6 months. And so I'll have to sacrifice and do that. But in any case, I welcome you. And I look forward to your presentation very much. The presentation will be presented by Dr. Dan A. Polhemus, an aquatic ecosystems conservation expert with the U.S. Fish and Wildlife Service in Hawaii. Dr. Polhemus manages the aquatic ecosystem conservation and environmental contaminants program for the Pacific Islands Fish and Wildlife Office of the U.S. Fish and Wildlife Service in Hawaii, a position he has held since 2010. Prior to this, he also managed the Division of Aquatic Resources for the state of Hawaii. He has served several times as the chair of the Monument Management Board for the incredible Marine National Monument and World Heritage Site in both state and federal roles. He was born in California, raised in Colorado, perfect preparation for living in Hawaii. His over 30 years of experience in freshwater and nearshore marine ecosystem research throughout the Indo-Pacific region. He's author of 220 peer-reviewed scientific publications, 2 books, and of course, numerous agency reports. And I'd like to thank Dr. Polhemus for participating in this. And with that, I will turn the program over to you.
All right, the title of my presentation is The World Does Not Stand Still, Understanding the Impacts of Climate Change in Papahanaumokuakea Marine National Monument. And good morning, afternoon, or evening to our viewers, wherever they might be. And I realize I'm the last thing between you and happy hour, so we'll just move ahead and take a deep dive into the climate change in Papahanaumokuakea. But I'm going to move fast, so if you have questions, catch up with me later by email. Okay, Papahanaumokuakea Marine National Monument occupies the northwestern 2/3 of the Hawaiian archipelago. It was first protected by President Roosevelt in 1903 as a series of refuges. The surrounding waters were protected by President Clinton in 2000. In 2006, it became a Marine National Monument, and in 2016, it was greatly expanded by President Obama. So the current large monument extends out to the borders of the exclusive economic zone and looks somewhat like a melted popsicle. If you take the boundaries of the old monument and put them on the United States, you will see it's a big place. In fact, the old monument would extend from Dallas, Texas to Las Vegas, Nevada, if you laid it on the CONUS. And with the new borders, actually, it would extend clear on out to the coast of California. It is 583,000 square miles in size. That makes it larger than all of our national parks combined. It harbors 7,000 marine species, including many federally protected species, 140 native Hawaiian cultural sites, and it was designated in 2010 as a World Heritage Site for both its natural and cultural values. The monument's very remote. You have to go at least 2,500 to 3,000 miles in any direction to find any other major landmass other than other small islands. But that said, being out in the middle of the Pacific does not mean it is not influenced by the remainder of the planet. And as we know, the planet has been getting warmer. And so atmospheric CO2 in July, summer, we tend to have a maximum on that because of plant growth in the Northern Hemisphere, was 419 parts per million. That's a 33% increase over the 64 years we've been tracking it up at the Mauna Loa Observatory, which is also in Hawaii, and that's where we get our CO2 curve. As a result, we have these climate-linked stressors for the monument. We have rising sea and air temperatures, we have rising sea level, higher incidence of severe storms and waves, changes in precipitation, and changing ocean chemistry in the form of decreasing ocean pH, which is known colloquially as ocean acidification. Some of this has been covered by previous speakers, so I won't dwell on it too heavily. Global mean surface temperature has been rising steadily since about the late 1800s and more severely and acutely in recent decades. Clearly, we know the planet's warming up. The problem is we do not have any long-term weather stations in the monument, partly because they're on towers and albatross and other seabirds run into them. So the refuge people have not been that eager to have them put up. But the problem is then that we lack long-term temperature and precipitation data for the terrestrial systems in the monument. But I think it can be assumed that just like the rest of the world, the monument has gotten warmer over time. And you can look at the main Hawaiian islands and realize this is probably true because back in 2019, we had our hottest summer ever. Lihue on Kauai is a station with 114 years of record. In 2019, it broke its daily record 52 times. That's all but unheard of for a station with that long a period of record. And similarly, hot temperatures were playing out across the entire archipelago. In terms of ocean heat content, that mirrors the rise in atmospheric heat. And as was mentioned earlier, in fact, basically at the surface exceeds atmospheric heat. The trend from 1880 to 2020 is up, as the EPA graph shows. The Eastern Pacific is somewhat slower in terms of this rate of increase, but certainly still rising. The rising ocean temperatures have consequences ecologically. in the form of coral bleaching. Increasing ocean heat content causes corals to expel their zooxanthellae. The first recorded instances in Hawaii of this were 20 years ago. They were in the monument because the monument, being further north, is somewhat more temperate. It has slightly warmer summers, slightly cooler winters. But since that time, periodic coral bleaching has now spread to the entire Hawaiian island chain. And there's no indication that that will stop. Severe bleaching was seen during the last major El Nino event in 2015 at Lysianski, which is one of our atolls up in the northwest end of the monument. We lost, in some cases, 95% of our coral cover at certain sites. And you can see here the difference between September 2014 and August 2015. On the east side of Lysianski, coral cover went down from 70% to 1%. And although it's recovered a bit, the rate of recovery has actually been rather slow. Such events are predicted to become more frequent by modeling, and essentially by 2030, the projection is every pixel in the Pacific, in the Indo-Pacific, that contains coral will bleach to some extent, perhaps not fatally, but you will probably be able to detect some bleaching impact by 2030 in every place that has coral. Sea surface temperature trends, ocean heat content, it's not evenly distributed across the planet. There are some areas that are cooler, some areas that are warmer. The monument's sort of right in the middle, but our far northwestern end up toward Midway actually runs warmer than the Pacific as a whole. As has been noted earlier, a lot of these heat events are piggybacked on the ENSO cycle, the El Nino La Nina cycle, and you can see that this comes along in about a 2 to 3 to 4 year trend. And so if you've got an El Nino, it's going to exacerbate heat effects. If you've got a La Nina, which you have right now, you get a few years break to think about what comes next. The ENSO fault runs on top of a larger cycle called the Pacific Decadal Oscillation, which is actually multi-decadal, but you can see that it bounces around on top. We are going into a warmer PDO at this point, so the next set of La Ninas will probably be, El Ninos will probably be more extreme heat events than they were in the past couple of decades. Sea level rise shows a steady upward trend globally. It's about 3.42 millimeters a year across the planet. We are about that same rate here in Hawaii. There are a few differences because of the fact that some of our volcanoes are either sinking or rising, so it's not a uniform 3.4 across the whole chain, but this is a reasonable approximation for the monument. Global rates are also not evenly distributed, and you can see that it's actually rising faster up in the northwestern end by Midway than it is down in the main Hawaiian Islands. You can model this by simply pulling the water up on your GIS plot. But what you'll see is if you just pull it up passively like a bathtub, it doesn't tell you the whole story. Once you put wave forcing on it from storms and other events, then you see what really happens. This is liaison with and without forcing. Forcing is on the right, and you can see that waves actually will push over quite a bit of Laysan if we end up with 2 meters of sea level rise. Similarly, we have some real vulnerabilities at Midway. This is Eastern Island, where the air base was in World War II, and under a 2 meter sea level rise, essentially most of that island is inundated in high wave events. Even at Sand Island, which is our base of operations at this time, you can see about half of that is vulnerable, which is something we have to take into account because this is our main base for managing them. In terms of precipitation, as noted, we don't have good records for the monument. We don't have permanent weather stations, but in the main Hawaiian Islands, the plantations did care about water and stream flow. They have very good gauging records, and there, over the last 90 years, we have steady declines in both precipitation and stream flow. It's basically a slow, steady decline, and the precipitation has become more episodic and less continuous. Tropical storms, they decrease in number in a warming climate, but they get stronger. The individual storms actually are stronger, and they tend to intensify more quickly. This happened to us with Hurricane Malacca in October 2018. This storm formed to the east of us, hooked under us, came up north. We haven't had hurricanes in the monument much over the last few centuries. It rolled right over French Frigate Shoals, and it went from a Category 1 to a Category 4 in only 30 hours. We estimated 12-foot seas based on the ASCAT. We had nobody there to observe it. The result was fairly dramatic. You can see that this is East Island, where most of our green sea turtles nested. On 5 May 2018, it was pretty intact. But on 18 October 2018, it was all but gone, and the remnants had actually been shifted in position. There's been a small bit of redeposition since then, but this was a vegetated island. It's now basically a mobile sandspit. Similarly, French Frigate Shoals was one of our intermediate bases of operations. It's an old airstrip that was built during World War II. You can see how it was heavily overwashed and eroded. This again took out green sea turtle nesting sites. Interestingly enough, because of the way that the winds were spinning, the big waves came from inside the lagoon, which is normally a more sheltered area, but that's where they came from. That said, in the upper left corner of the photo, you can see that's the reef on the outside of the lagoon, and that area got hit hard as well. This is Rapture Reef, which was one of our iconic areas in this monument. We used it on all of our promotional materials. Essentially, before Hurricane Malacca, it was a beautiful coral paradise. After Hurricane Malacca, it was essentially a coral wasteland. We're now basically sending cruises up there maybe once or twice a year when we can get the money to see the rate at which this is going to recover. We are seeing a bit of recovery, but once again, it's slow. Finally, changing ocean chemistry, which is known as ocean acidification, but if the oceans are acidic, we're all dead. So it's really sort of the oceans are becoming less basic, which doesn't sound as good. In any case, it's happening. It's hard to quantify. We've been trying in the monument, but there are a lot of other factors that come into play, especially in nearshore waters. But this is one of those trends that down is bad, because down does mean that your ocean is getting more acidic. One thing we do have in Hawaii is a offshore pelagic ocean monitoring site that has been there since 1988. It's called Station Aloha, and it has had standardized ocean monitoring ever since the late 1980s. And there we can see that as atmospheric CO2 has risen at Mauna Loa, we have a very clear trend of declining ocean pH at Station Aloha. So this would indicate that, yes, this is probably playing out in the waters around the monument as well. And it does change the aragonite saturation point and the ability of corals and things like zooplankton to calcify. And that's certainly a concern. Okay, and ocean pH, like most of these other trends, is not evenly distributed. And like all these other trends, it seems to be concentrated more acutely at the far northwestern end of our monument up by Midway. Okay, so the projected values we have going forward, we're going to have increasing ocean heat content. We probably pick up an extra degree of sea surface temperature Celsius, realized, by 2050. That's multiple Fahrenheit, and 2 to 3 by 2100. Sea level will probably come up by 35 centimeters by 2050, 1 to 1.5 meters by 2100, and that might be conservative. We already know that tropical storms are now coming into the monument like they never did before, and we just have to deal with those. It's not clear what rainfall trends will do, but a warmer atmosphere does hold more water. So certainly, even if it doesn't rain more, evaporative demand could dry the islands, and ocean surface pH will steadily decline, probably to 7.9 by 2050, maybe 7.7 by 2100. Not acidic by any means, but could have biological effects. Okay, what do we do about this? The monument is co-managed by the Fish and Wildlife Service, NOAA, the state of Hawaii. The co-trustees developed a management plan a year after the monument was set up in 2007. For political reasons at that time, it didn't make any mention of climate change. However, by 2010, it was evident this needed to be corrected. So the co-trustees passed a resolution that said, climate change is a clear threat to the integrity of Papahanaumokuakea. In 2011, they set up a steering committee and said, develop a climate change action plan. That was done. 13 members of the steering committee met twice a month for 5 months. They developed an options paper. This was followed by 2 expert workshops that brought together subject matter experts on climate change in the Pacific, and this included both biological and cultural experts. The first workshop was in 2012. They drafted a climate change action plan. The second workshop then fleshed out the strategies to implement the plan. Okay, the priority actions. Implement transdisciplinary research and monitoring. You can't manage what you don't know is happening. Then implement appropriate adaptive actions to the extent possible. And you've seen we have some issues regarding rising sea levels. We're going to have to deal with that. That's coming whether we like it or not. You have to account for climate change in your operations and logistical planning. Will our runway still be operational, et cetera? And contribute toward regional and national efforts to raise awareness, like this particular session, and then serve as an international example for other World Heritage Sites. Okay, so following that workshop, we had a revised plan in 2013. We presented it to the board in 2015. It was edited and commented on, and a final consensus draft was received final approval by all parties this year. We had a bit of a hiatus during the previous administration because they weren't pushing things like this all that heavily. Okay, you can find the climate change vulnerability assessment that underpinned all this. It was published in the NOAA Marine Sanctuaries Conservation Series in June 2016. It is available online, and if you want it, I can send you the link. Okay, finally, an interesting thought as I wrap up. If you are age 30 or younger and viewing this, no month of your life has had below average global temperatures based on records from 1880 to the present. So in that regard, everybody under 30 is above average. And the final take-home message is really isolation is no defense. Papahanaumokuakea is one of the most isolated protected areas in World Heritage Sites on the planet, but it has still experienced rising seas, island overwash, rising ocean temperatures, coral bleaching, and an increased incidence of severe storms, and those will all continue. And although we can monitor these symptoms and make certain adaptations to them, the only solution is to address the underlying causes, and hopefully that will happen, or we'll take steps toward it in the upcoming meeting next week. So the future is here. Now, how do we manage for it? Thank you.
Thank you. I appreciate that very much. And again, it gives us a lot to think about, some of which is not that, well, let's say it's challenging to think about. I understand the last UN report suggested that even if we were to stop all of the carbon emissions immediately, that the chain reaction would continue because of the carbon that has been emitted thus far. What do you have a comment on that?
Yeah, well, if you drive your car across a railroad track in front of an approaching train, the train cannot stop immediately. You're going to get hit. Okay, yeah. That's the problem we largely have with climate. We've put enough CO2 in the atmosphere that we will deal with the consequences of it in the near-term future. The question is, do we want to be dealing with even more severe consequences in the longer-term future? Because it doesn't get better, okay? So we're not doing this for us necessarily. We're doing this for my kids and my kids' kids, because right now we've sort of bought the ticket and we're going to take the ride, but that doesn't mean we should make everybody else take the ride.
Right. And I suppose there are some ways that we could ameliorate these outcomes. You're talking about building seawalls and that sort of thing. I'm sure that
adaptation is really the where we are at right now. We need to understand how fast the changes are going to come. We need to understand essentially where they're going to play out, both in terms of physical changes, ecological changes, and to then the best extent we need to manage for that. Okay, and clearly managing symptoms is like putting a Band-Aid on things. It helps, but what you need to do is get at the underlying causes. Okay, and obviously that's what the upcoming meeting is intended to try to do, is get at the underlying sources and causes of the problem rather than just running around and trying to bandage the symptoms.
Yeah, well, I've been working in the Western Pacific recently, and it's been an eye-opener to me. And of course, we've got the Marshalls, we've got the Atolls out there in Micronesia. It seems as though people put up, I don't think, convincing arguments that, they might not completely wash away. There might be sedimentation that's caught by the elements that are there, but that doesn't mean that sedimentation is going to be of the kind that would produce the lenses of fresh water that are necessary for human life. I understand Australia for a time had a program. They were planning for the relocation of people in these low-lying islands. I mean, you go to the Marshalls, and I've flown out of one of those islands get out of the airplane and the ocean is 2 feet below, and you get a big storm and it just washes over the runway. So, I mean, that's something that Australia abandoned because they elected a conservative government. But I suppose that's something that we might want to be thinking about. There are hundreds of atolls out there in Micronesia that are going to become uninhabitable. Some people say within 50 years. I mean, that's a dire thought, but perhaps something that someone should be giving some attention to. I mean, that's not solving the big problems, but it's solving a problem. There are hundreds of these islands, and every one of those islands has developed a somewhat unique culture where they find it difficult to speak the language of the nearest island or nearest atoll. So what are you going to do with those people? It's not the population of Syria, but nonetheless they're human beings, and nonetheless they've got these unique cultures that will soon cease to exist. I mean, that's just one in the constellation of all these issues that we've been talking about. I suppose it's not the biggest issue, but certainly there are those issues, and perhaps we should be given, as an anthropologist, we might want to think about that sort of thing. What are we losing there culturally on a global basis?
Well, life on atolls is likely to be increasingly challenging as we move forward in the current century. I've done a fair bit of work in the Marshall Islands and in the Maldives. My talk was an excerpt out of a longer 45-minute talk. Then I couldn't go into everything, but one thing I do talk about in the longer talk is that there's a concept of crossover points, where an atoll is generally a carbonate platform with some alluvium and sand on top. As long as the waves are hitting the carbonate, you're fine. As soon as they get to the point where they can attack the alluvium, you lose your island quickly. And as you pointed out, just like we saw with the loss of East Island at French Frigate Shoals and Hurricane Malacca, you might get sand spits reforming, but they're going to move around. They're going to be in different places. They aren't particularly suitable areas to live on because they're not solid and stable. It depends on where you are in the Pacific. It depends on a whole bunch of different oceanographic factors. The ocean surface itself is not flat. But crossover point problems are probably going to start up as early as 2040, 2050 for many atoll island
I've heard,
states. And in the Maldives, at least, they make their living by picking the pockets of foreign tourists, especially very rich ones who come down from Eurasia, and they put it away in a sovereign wealth fund. And one of the things that they were discussing was actually buying an enclave in Western Australia to where they could move if the Maldives, in fact, completely went underwater, because at least they would still be Indian Ocean people. And I don't know the status of those discussions. Perhaps the current government in Australia isn't as interested, but certainly that was under discussion when I worked in the Maldives in the early 2000s.
I don't want to, dominate. You guys are the expert, but I do want to clarify something. I hope I wasn't misunderstood when I was saying that, the INSO cycle and the Pacific Decadal Oscillation and other similar long-term climatic oscillations. It goes back to this idea that people have in their head that global warming just means it's going to get hotter. And it will get hotter, there's no doubt about that, but it will also have, and correct me if I'm wrong, there are going to be places, it's like when Trump went to Chicago and it was very cold and snowing. He said we can blame this on global warming. It's not just warming; it's really upsetting the whole environmental system of the Earth, and it sometimes is expressed not just by getting hotter. It's expressed by tides, and it's expressed by unexpected cool periods in certain parts of the Earth. And now that I'm speaking to the experts, would you agree with that? I mean, I realize that it's dangerous to say, well, yes, global warming, but on the other hand, it might be worth thinking about how one goes about explaining these strange anomalies, not just the intensity of storms and all of that. People could kind of get that. But where we have, droughts and where we have cold snaps that are less predictable than in the past, I'm just wondering how that fits into the big picture of global environmental change, or if it doesn't.
Well, just remember that climate is what you expect and weather is what you get. Okay, so they're different things. Okay,
Yeah.
Climate is a basic statistical envelope based on weather over time. Okay, and as climate changes, what you're starting to see is oscillations between extremes. Look at what happened in Northern California this last week. They were in a horrible drought with a terrible wildfire season, and suddenly they had more water than they possibly needed all at once. Okay. And these are the sorts of things that you may see, these sort of whiplash events that go back and forth. So yeah, I mean, it's just, and every time you have an extreme event at one end or the other, it moves that statistical envelope. So climate, changes over time, because every time you see a weather extreme that was a non-analog event, you just move that statistical climate envelope a bit.
Yeah. Well, the other thing is, one of our speakers tomorrow will be the Australian traditional knowledge broker, and he lives in Kakadu, and so he has this intimate relationship with the environment. People that live in houses don't necessarily, traditional houses. I mean, we had a big storm in Baltimore the other day. I didn't even know it happened. I just ignored it. I didn't even hear it. But if you live on the land, you're much more attuned to those kinds of events. And what he's saying is that he's pretty sure, or his people are pretty sure, that things are much less predictable. And that's a problem, because one of the things that they do is they manage the fuel load. They're addressing the fire regime. And they did know at some time in the past, okay, now it's dry enough. Now we're going to start the fires, and we know that it's going to rain and help us put it out. And he said, we can't do that anymore. About the time that we think it's time to start the fire, it rains. And then we have to wait. And then we just don't know. We have much less certainty about what's going to happen next in terms of the weather.
Well, a good example of weather versus
you can put
climate.
that down to what people say, if you don't like the weather, wait 5 minutes. But these are people that really depend upon their knowledge of how the sequence of weather events occurs. And what they're telling us is that they can't depend upon that anymore. I'm just wondering what that has to do with climate change, if anything.
Well, consider in California, some places just got 6 to 8 inches of rain, okay? But they're still in a drought.
Yeah.
Because that didn't change the long-term climate problem. It was simply a rather extreme and, isolated weather event. But they'd need a dozen of those to actually be out of their climatological drought problem.
Evelyn, yeah.
Yeah, Evelyn, you had some great thoughts that you shared in the Q&A box. If you want to share it with the group at large.
Sure. I would speak just briefly first to the reduced predictability of a lot of the threats that we're now exposed to throughout the world. And I think that the Everglades is a great example where, we have these storms that are coming at different intervals than they had been. We're in a positive phase of the Atlantic multidecadal oscillation that does bring just naturally less predictability, and that combined with accelerating changes in tropical storm periodicity and sea level rise is really creating some complicated settings for the hydrologic modeling that we've been doing a lot of to figure out when and where to put fresh water. We do have some scientists who are working with the wobbles in all of those different climate variables and who, upon analyzing those wobbles, say that in 20 years, we'll know enough about the changing wobbliness to have much better predictions about the wobbles moving forward. But that doesn't help us right now. It helps us know when our planning may become a little easier because the math gives us more certainty. There was a question, and you guys were talking about, and I hope I'm hitting the right one that Nancy Brown wanted me to talk more about for South Florida. And I think you were talking about the archaeological and cultural resources at risk, and what those features are for those resources. And I didn't really talk about that in my talk, but we do have a lot of archaeological resources at risk in the Everglades, particularly these shell midden sites that people lived in for thousands of years, and are now protected, and yet also exposed to, of course, all those factors that Dan was talking about too, in terms of acidifying water and the salt that's coming in. So this is a problem in South Florida, again, because we're low lying and the topographic relief is so shallow, and particularly those cultural sites along the coast of South Florida are just increasingly inundated with saltwater and our king tides. And we are trying, the city of Miami has been very progressive in putting together climate action plans, including recommendations for floodwater management that would become part of our comprehensive way of fixing the Everglades. And some ways of dealing with floodwaters are useful in South Florida. Others are not, including building seawalls that are that continue to be part of discussions and even are happening, but they aren't very effective because our porous aquifer allows for that water to move underground, and even if you stop it with the seawall. So we're confronted by a lot of changes that are difficult to deal with because of that bedrock that we're on, and we have to get creative. And one of the probably best mitigation approaches is using green architecture, using our living seawalls, which are like, enhancing our mangrove forests along our coastlines. They do build soil. They are great at mitigating storm surge and so forth. And we have very, very proactive local government now on these topics. So, we're hoping that we can interact with them more to do what we can to buy time, which is, I think, what we have to plan for.
Buying time, yeah, and hope that people will look beyond, the immediate profit that can be gained by continuing this kind of crazy extraction of fossil fuels and burning fossil fuels, and just not looking beyond that, I think very intentionally ignoring all of that sort of thing. That's a really powerful, there's so much money there that, it's a daunting project. So I do hope that people pay attention to what happened, at the next COP meeting. And
for sure.
Yeah. And I also hope that we can stay in touch. This is really at the center of what ICOMOS and UNESCO should be concerned with. It is actually the center. For ICOMOS, our decadal scientific plan is focused on climate change, for whatever that's worth. But we need folks that actually study this and have lived it to provide advice and to keep up with what you're doing. So hopefully we can figure out a way to do that. So any other questions? I lose track of time. I don't know what that means, but I lose track of time.
I see one in the chat that I was just typing, and it might be just quicker to say an answer to it. I don't know, from Victoria, about whether there's a washover model for the Everglades, bathtub type model that Dan was talking about. And yeah, we have those. I showed one in my talk that went by probably too fast, that showed that if we bring more fresh water in, we can build up soils in ways that accumulate peats faster and buy us again some time to adapt to sea level rise. But we also have the ecological models that are building those peak collapse and building processes into them that really help understand where the vulnerabilities are in the landscape, in the Everglades landscape, and combining that with sort of blue spot analyses like of where the flood vulnerabilities are in the built environment, to see how the restoration of fresh water and the diversion of canal water interact to change both flooding in the Everglades and flooding in urban Miami. So yeah, there's a ton of flood modeling going on, and lots of work on that you can find in the published literature and in our book. I don't mean to be trying to sell the book or anything like that. It's just that we do have the outcomes in these models shown, in their pretty detail.
Terrific. All right. Again, I want to thank you on behalf of U.S. ICOMOS, and humanity for your hard work, hard essential work, and good luck. Good luck to us all. Thank you again. And I do hope we figure out some way to continue to tap into your wisdom and your knowledge, okay? We'll have to give that some thought. I've really been so impressed with what I've heard here today. I really appreciate it. All right, thank you so much. And I hope to see you all again and someday meet you in person.
Thank you.
Likewise, thank you so much.